Welcome to Devoxx Belgium. I have a camera and a microphone. Let's have a talk with some of the speakers and the guests.
My name is Moritz Halbritter. I work in the Spring engineering team, particularly on Spring Boot, and I'm also the team lead for Start.Spring.io, so the website where you can create your Spring projects.
The most promoted website ever by George Sloan?
Yes, it's I think second favorite place on the internet or something like that.
Oh wow!
I have no idea what the first one is. I guess production.
And you're here as a speaker?
I'm here as a speaker, yes.
Yeah.
I did a talk together with Anna Maria from the Java team about Project Leyden together with Spring Boot.
Yeah. Project Leyden, so the goal is faster startup, ahead of time compilation,
Right.
with what GraalVM is doing. What is the status of this project?
Project Leyden has want to fix the problem that Java is slow to start up, essentially. And the idea is that you can shift stuff which you normally would do at runtime, you would do before that. Like you would, for example, collect profiling information, compile code ahead of time, essentially, while doing a training run. And then you can use this cache and enable it later when you're running. And this gives you a better startup time and a little less memory usage.
And this profiling is analyzing which code is used and how code is used correctly?
Right. So usually when running a JVM, it observes the code and all the code paths and stuff, and then it collects profiling information, and then the C2 compiler uses, or the JIT compiler uses this information to create like highly optimized code. And this is the same when you're doing a training run. And in the training run, you collect that stuff, but like not while running in production, but while you're doing a training run, and then this data is captured and stored inside the cache. So in production, you can reuse that data later.
And this is a bit the main difference of the full ahead-of-time compilation, where you don't have the Java code anymore and not compile it at runtime, correct?
Right. So people tend to compare like GraalVM and Project Leyden, but I think they are not really like comparable, because like GraalVM also gives you like a really nice startup time, even more than Project Leyden, but GraalVM has other benefits like reduced memory consumption and stuff like that, because they analyze your application, do a closed world analysis, and then only put stuff in the native image which actually needs to be there, and they can aggressively optimize that stuff. So you get like even better startup numbers. But of course, in software engineering, there's always a trade-off. Yeah, and the trade-off on the GraalVM side is that you may have problems with third-party libraries, but the GraalVM team is heavily working on that one. And with Project Leyden, it's more like you need to think about the training run, but otherwise it has like the same semantics like a normal JVM. So you can do reflection, you can do all the other stuff. So it's not restricted, but you don't get those crazy startup performance numbers. But it's still like really impressive.
It's really impressive, and it's ongoing because this project is not finished yet.
Right. The Project Leyden is currently a working project, and they take like working units which are already finished and put them in general available JDKs. For example, Java 24 has this AOT cache, and they collect with Java 25, they now collect profile information, but this whole compile code ahead of time and put it in the cache is still in early access phase.
Yeah. And that's a bit how the JDK evolves. You have these long-running projects, and then you have the JEPs, which are building blocks to achieve the goal of the project.
Right. Yeah.
So there is no clear answer yet when we will have a project Leyden which is finished, but along the road we get these improvements.
Right. Yeah.
Is this something which can also already be used if you are a Spring developer? These improvements?
So with Spring Boot 3, I think 3.3 or something like that, we added support for CDS, so class data sharing, which was the predecessor of AOT cache. And it turns out that all the stuff we did for the CDS is also applicable to AOT cache. So there is a mode where you can extract your big Uber jar, which comes out of Maven package or Gradle build, and then you can extract that jar into a format which is like AOT cache compatible, and then you can run that. So the workflow normally works like this: you build your Uber jar, you extract the Uber jar into an AOT cache capable format, and then you do your training run, and then you use this extracted jar also in production. So, for example, put it in a Docker container and point it to the cache you created in the warm-up phase, and then you can use it. And it's the same with Leyden. It doesn't change, like the workflow doesn't change. It's only like a different JDK.
And the training run, that means that you run your application and you put the load on it similarly like it would be in production, correct?
Right. So I said there's trade-offs everywhere, and here's the trade-off of Leyden. What they did is the training run should be as close to production as possible to get the optimal benefit. So there are two ways to do it essentially. One way is the easy way, and this is like only start your Spring application to a certain point and then just stop it so that it caches all the class loading. This already gives you a lot of startup performance, like we're talking from 3 to 3 seconds in my talk down to 0.8 seconds or something like that. But it doesn't give you like profile information, and it doesn't give you like optimized compiled code for a hot path. But this is the easy way. This is like easily done. The different way is to get your training run close to production. For that, you usually need like either great integration tests, or you need to somehow mirror production data against your training run. And I'm not sure what your chief information security officer thinks of that idea. So
depends on the kind of applications. But this reminds me a bit of what CRaC is doing. So there also you can take a snapshot. What's the difference between the CRaC way and the Leyden way?
Yeah, right. So CRaC is the coordinated restore at checkpoint, and it already says like it's coordinated. So the application has to do stuff when you take the checkpoints, and one of the trade-offs the CRaC inventors did is that you need to close all files, because this stuff doesn't work on a JVM level, but it works on a process level of the operating system, which is only supported on Linux. And there it's using, I think, CRIO it's called, which essentially takes a snapshot of the whole process. And you can restore that very fast, and it's instantly hot because it captures the whole JIT and all the code cache and stuff like that. But the trade-off is that when you take that snapshot, you need to close all files and sockets and stuff like this.
And reopen them when you restart.
And you have to reopen when you restart.
So there are some code changes there, while with Leyden it could be just the same code, but with the test run.
Yeah. So the one important goal of Leyden is to not change Java semantics. So they don't expect you to change your code. It should work like out of the box without any changes.
And if you want to use this, you have this training run somewhere in your build process, for instance, that you have.
Yeah, you need a training run, but even for the training run, you do not need to change your code.
Okay. What is the most important takeaway from the talk?
The most important takeaway, I would say, is that even now with JDK 25, you have something from Leyden, from Project Leyden, which is general availability. It has the same quality stuff like every JDK release has. You can just enable that with your Spring Boot application, and you get like a performance factor or a startup factor of maybe 4x or something like that. Like it starts like 4 times faster, which is just crazy.
And that's by enabling the preview features, or that's just a configuration in Spring?
That is like only extract the thing, do a small warm-up. It doesn't even have to be the production warm-up, just like do the easy warm-up.
Until your main method gets called, actually.
Right, yeah, there's a flag which you can pass, just look it up in our documentation, and then you get like a startup performance of 4x. This is what I would do.
Yeah, which can be very helpful if you have a scaling application, for instance, that you can run additional Dockers very fast.
Yeah, so the reason why people want to have like a fast startup is because they like to compare numbers. Like every number is good for comparison, but like the real operational value is if you do dynamic scaling. So if you get like a lot of requests, you want to dynamically scale your applications, and then of course they have to start up fast.
My name is John Cecerralli, and I'm here at my first Java developer conference in many years.
And is something going on?
It seems like there's a lot going on.
What's the main thing that you're seeing?
Oh, well, it's all AI. It's all about building agents and how our Java programs can interact with AI, can feed into the LLMs, can pull things out of the LLMs. So yeah, exciting stuff.
And is Java the right thing?
I think that, LLMs are part of the story, but, LLMs can't do everything. They need to offload things to the agents, and you should absolutely be building those agents in Java. Yeah.
Mm-hmm. You've been in Java for a long time.
Yes.
What's the main evolution going on in OpenJDK for you?
Oh, in OpenJDK, the thing I'm looking most closely at is Project Leyden right now. I work for Azul. We have Azul Prime, and we've been doing AOT profiling and AOT compilation for a long time with our Ready Now technology and with our cloud native compiler. So it's really interesting to see what's happening in the warm-up sphere. Where we're looking very closely at Leyden. We're seeing, how we're gonna interact with it, to what extent we're going to uptake it in our builds of OpenJDK versus to what extent we'll, kind of keep doing this thing we've been doing ever since JDK 8. But Leyden is a thing that's very interesting for me. And then performance, I'm very interested in both what's happening at the JVM level and then what's happening at the language level around performance. I'm a performance guy, so that's what I'm interested in.
And performance, is that also impacted by how we evolve? Like we have the Graviton instance, ARM-based computers. Does this have any impact?
Yeah, Graviton is really interesting. The ARM64. I mean, we as the Java community as a whole have been optimizing for the x86 architecture for
many years,
many years, right? And Graviton is new, and so we're really seeing in JDK 25, you're seeing OpenJDK starting to catch up and starting to do some very interesting optimizations that we've had in Azul Prime for a while around loop unrolling and so forth, and effectively final to get the code speed up, because people, we do a lot of benchmarking, and Java runs slower on ARM64 than it does on x86. So people look at transitioning their workloads from x86 to ARM because they're going to save all this money, and then they do the calculations, right? And they go, oh, well, x86 costs this, Graviton costs that, and so I'll save this much money. But they're not factoring in that they're going to actually have to run more compute to handle the same workloads, because their Java is going to run slower. At least OpenJDK Java was going to run slower on Graviton. We at Azul are optimizing the heck out of Graviton. OpenJDK is starting to pick up some of those optimizations that we've had for a couple of years, and it's starting to catch up. And I'm sure that ARM64 will be as faster than x86 very soon.
And you mentioned Project Leyden and then the products from Azul. Do we see there's a lot of other evolutions, like you have TornadoVM, which already is working a long time on GPU support, which is also coming in Project Babylon, I think. So all these different projects, they run for a long time. So people are really waiting for a new feature. Could be a bit disappointed, but on the other hand, it's all stable, which comes out of these changes, correct?
Well, as Gosling once said, aggressive innovation is good at the edges, but not at the core. Aggressive innovation in java.lang.string would be a very bad thing, right? When I'm looking at the JVM level, I mean, of course, I'm a product manager. I'd love to have some shiny whiz-bang new feature to go like, oh my God, wow, that's cool every day. But really what our customers want is they want rock-solid stability. They want reliability. They want performance, right? They want it to just work as fast as possible and to deliver the best the best experience, customer experience, the best reliability, the lowest cloud costs, and the lowest emissions. And that's what they want. But there is a lot of stuff happening, outside of just OpenJDK and Prime. Obviously, some turbulence in the GraalVM world with the Java announcement, with the Java team's announcement that they were kind of disengaging from GraalVM, and then TornadoVM starting to come up. So there's lots of players in the market, and then even inside OpenJDK, different contributors. It's exciting that Shenandoah now has generational support. So at the JVM level, there's at these conferences, people typically come to hear about fancy new language patterns and frameworks and so forth. I operate at the JVM level. There's a lot of exciting stuff happening at the JVM level too.
If you look into OpenJDK and how it evolves, they say Java is boring because the Java tomorrow will be just as stable as the Java yesterday.
Right.
But what is happening inside is really fascinating.
It's really fascinating. It really is. Yeah. And we just keep, and AI is opening up a lot of things, right? A lot of, at a very, very fine level. We are now using AI to analyze optimization patterns for the JIT compiler and unearth opportunities for faster code that at a rate that we couldn't have done before. So it's not just about Java developers coding in AI. It's about us, the JVM people, using AI to improve the Java runtime that the Java developers run on. So it's all exciting stuff.
I'm Christos Kotselidis. I'm a professor at the University of Manchester, and together with the TornadoVM team, we have two talks about how to accelerate Java programs on GPUs.
I'm Michalis Papadimitriou. I'm a research fellow at the University of Manchester. I'm part of the TornadoVM team, and I'm here because I'm presenting our latest work, GPU Llama 3.java, which is a full Java inference engine for LLMs.
Yeah, okay. The rest of the team is behind the cameras.
Yes. Thanos and Mary.
You're with the whole team representing your system. I know TornadoVM a bit. Can you explain in 2 sentences what it is?
Yeah, TornadoVM essentially is a plugin to all JVM distributions that enables Java developers to write and accelerate their code on GPUs.
Okay.
That's it.
GPUs, which are a hot topic, everything AI related.
That's true. Like we have been discussing with the team like 5 years ago. The topic of GPUs wouldn't even be a talk in Devoxx or any conference, and now today we have 7 talks on GPUs on Java, which is becoming more important.
So, what is the advantage? Why would I want to run my code on a GPU?
I would say the big advantage is that if you have a lot of parallelism in your code and you want to harness a device that can offer more performance because GPUs have more cores and they are suitable for kind of workloads, it would make sense to offload some of it on the GPUs. So there are workloads like traditional machine learning or LLMs, which is the hot topic now, that can benefit especially for large models running on GPUs.
Mm-hmm. Can you maybe give an example of what can be improved for AI appliance?
Yeah, I think what's very interesting is that you can build your own AI libraries in pure Java, and this is what we try to demonstrate with this project, the GPU Llama with Tornado, is that now through TornadoVM you have all the tools available to build AI-ready libraries in pure Java. So what one have seen as llama.c++, that is just a C++ program that runs inference on CPUs, GPUs. We can have the same equivalent with pure Java, and it's not intimidating anymore to write GPU code as a Java programmer. The entry barrier, it's much lower with frameworks like TornadoVM. So that's the use case that it's been made very obvious with LLMs.
As you said, you have a history that AI didn't exist when you started with TornadoVM, so you found a niche, and now certainly this appears to be a very hot topic. We also see within the OpenJDK project that some things are going on around this topic. So you have the vector API, which is more or less related to calculations. Then you have Project Babylon. Are they competitors? What's happening in OpenJDK and TornadoVM, or are you somewhere emerging into one thing?
I would say we are complementary approaches. So Tornado can work with Babylon and Babylon can work with TornadoVM. Essentially, Babylon it's more than just GPU acceleration because it involves techniques and methods for data structures, which we are very eager to adopt. We were one of the first adopters of Project Panama. So having Vector API, working with TornadoVM and the future with Babylon, this is something that we're really looking forward to because our objective is maximum performance. And actually, as Michalis can say, we have our demos which they combine Vector API and TornadoVM to run workloads?
Actually, Vector API and Project Panama, it's two of ideas that we built on top to have this pure Java GPU inference engine. And for us, Project Panama, it's great convenient because it simplified a lot how to load all these very large models that can be up to 20, 30 gigabytes. So for us, it's just a very big segments, and then you can use the TornadoVM API to split these segments into data structures that make sense for GPU. So Tornado is complementary to this project, so it's not like a competitor. Same thing is for Babylon, so Babylon has its own data structures, that it's something that we see in the foreseeable future to adopt in TornadoVM. So yeah, as I mentioned earlier, all the components are there and they're mature enough to start building AI libraries for GPU acceleration in pure Java, and this is what excites us the most.
If you didn't start with AI in mind, what was the initial goal of TornadoVM? What kind of applications, what kind of improvements can I gain with TornadoVM?
That's a really good question. When we started, like 10 years ago, building the system, we started out of curiosity.
Which is a great way to start.
Exactly. So we're thinking, okay, if GPUs or even other device like FPGAs become, let's say, commodity, what changes the JVM should make to accommodate them? So back then, we didn't have a use case. But throughout the years, we realized that there are use cases beyond AI, like traditional codes, that require acceleration. For example, this year, we had our first production deployment of TornadoVM. So now it's being used by the European Space Agency in the Gaia mission. So for our audience, the Gaia mission is the largest European space mission, where the Gaia spaceship takes pictures of our galaxy. So in the University of Geneva, they have a lot of data pipelines where they take the data, the pictures, and then they do very complex pipelines of processing those. And they use TornadoVM as part of a European project, Aero, and they managed to minimize the time from 1 month of processing to 5 days.
Oh, wow.
Yeah. And which means, if we look very closely, there are use cases that have been built in Java and they are in desperate need for high performance parallelism.
Yeah.
Hopefully we'll find more in the future.
If I want to try out TornadoVM, how complex is a Hello World example?
Well, we have simplified the process a lot. So if you want to run your first, let's say, Tornado program, you can go in our GitHub, which is TornadoVM. There's a super simplified installer script that you just run it. It's going to detect your Java version, your JDK. As we mentioned, we're a plugin for multiple JDK. So it doesn't matter if you're using GraalVM, Temurin, Zulu, whatever. It's going to detect it, and then it's going to install Tornado in your system. If you have a NVIDIA GPU, it's going to ask you if you want to run OpenCL or PTX. If you have Intel, it's going to ask if you want to have a SPIR-V, for example. It's simple as that. It's an interactive, let's say, CLI tool. It's gonna be there, and then you run a simple command as Tornado devices, and then you are ready to go. Yeah. And then we have plenty of examples, benchmarks, guides. Because as Christos mentioned, Tornado has been around for 10 years, which is great because we live in the LLM era. So even if you try ChatGPT and ask, I want to write a TornadoVM program, we have enough material online, and all these LLMs are trained with Tornado source code. So the entry barrier, as I mentioned again, is very, very low to write your first Java program with Tornado. So we invite you, give it a go, and give us your feedback if it's that easy.
If I want to add also, we are integrating with SDK Man. So hopefully in the next couple of months, you just go to SDK Man, and then it's even simpler than running a script.
Yes. Yeah. And because we talk about simplifying things. And since last week, TornadoVM is integrated with LangChain4j as a model provider. So you just import your LangChain4j, and then you have Tornado for free. So you just install Tornado, importing LangChain4j in your project, and you have now also the option to run inference on your local GPU through TornadoVM. So things become much, much easier. And because, with all this push towards AI, also for us, we iterate much faster. And, we get feedback that we didn't get in the past. So, things are much, much easier now.
Why doing AI and this kind of things with Java and not Python? Because Python seems to be the big player here, but Are you convinced Java is better?
It is a trap question. Okay, myself and all the group, we love Java. We have been doing research on JVMs for the last 20 years. I don't want to go discussions which language is better, but I would say that each language has its own strengths. And one of the strengths of Java is stability, security, and everything that we love about Java. So if somebody wants to use Python, let's say for training or making a prototype, that's fine. But if you want to go in production or even integrate AI into the large enterprise code bases that Java has, I would assume that somebody would like to stay in the ecosystem and use tools that are built within the Java ecosystem. So for me, people have the choice, and we are trying to enable Java developers to also have a choice within the Java ecosystem.
Also because as Java developers, we don't really like dependencies. Also for sometimes it's very difficult even to pursue dependencies through GNI to native code. So getting into Python as a Java developer, really, it's very against.
Hard,
yeah. So if the tools are available and they're mature enough to build similar libraries with Python and getting the same performance in just Java, why to add, one more dimension of complexity in your project, learning Python, keeping up with the libraries, rather than getting something and maintain something which is Java. And at the end of the day, you can really understand what's going on there.
Yeah.
What is the one thing I should remember from your talk?
If you're a Java developer and you're really looking forward to enter into native AI acceleration on the GPUs today, TornadoVM can offer you a platform, an ecosystem that can help all developers from writing code to deployment to debugging, because we have a vast amount of tools. They can start today, and we are looking very forward for the feedback to make it even better and more suitable for the use cases.